Okay, hello, beautiful people. Now, a couple of things. So, I have not been as consistent with the podcast because I've started a new project called EvolveWell. And my guest today is the Chief Technology Officer of that project. So, essentially, I'm going to be, of course, trying to be as consistent as possible in the coming months and really film a ton of episodes both in Serbian and in English, depending on, of course, who my guests are. But I just wanted to give you guys a heads up. I know that some of the people that watch the podcast and follow it have asked, where are the episodes, why are you not posting, etc. So I really hope for your sake and predominantly for my sake, I keep filming and I keep pushing because this is something that I really love to do and will continue to do so. So, for today's guest, I've spoken to Marko when we were in Ashland, Oregon for a company offsite, and you're going to see a beautiful backdrop of the mountains in Ashland. And basically, for today's conversation that you're going to listen, we've gone over mostly AI-related things. So artificial intelligence, large language models, machine learning. We touched a little bit on, Bitcoin, but in general, we've also talked about Marko's life because he's had an extremely diverse and, dare I say, fulfilling life in the scope of his domain. Now, Marko, before joining EvolveWell, was at Ascent Robotics, which is involved in work in terms of industrial robotics. And he lived in Japan for 7+ years. He was also a CTO there. I don't know if I've mentioned that. And I've known him for 20 years. Basically, he's been a friend for 20 years, and we have crossed paths yet again. And he joined EvolveWell at the beginning of the year. And I'm very happy that happened, as well as that we've had this conversation, because I think that, you guys can derive a lot of value. And we're also going to be talking more about what we do in the background in regards to EvolveWell. So that's going to be an ongoing conversation, of course. A little bit more about Marko. So he is a mechanical engineer by vocation, or rather by education, but he is also a AI software engineer. He's a very multifaceted individual and dips his toes in a lot of engineering related things, but of course outside of that has many interests as well, which we have discussed briefly in today's episode. I think that's it for the intro. Probably one of my kind of longest intros, but yeah, hope you guys enjoy today's episode. This is Kensho Talks. My name is Vuk Baletic, and dear listeners and viewers, now Marko Simić. Enjoy. Woo! What a day. Hey, Marko.
What a day. Hi.
How you doing?
Doing awesome. I mean,
look at where we are. Look at where we are, honestly. So I'll let you give me a little bit of background on yourself. And also, if you could, give me a little bit of background on the place we are and why we're here.
Sure. Sounds good. My name is Marko, originally from Serbia. Studied machine learning and robotics. Spent some time in Russia and US, and the past 10 years, around 10 years in Japan. Worked as a machine learning engineer for a bunch of years. Served as a CTO of a robotics and AI company. And since a few months ago, we're colleagues, and I serve as a CTO of a company called EvolveWell. And yeah, we're on a great journey of, personal growth, but also helping other people grow.
Exactly. And, it always interests me as a complete novice in terms of AI and your work in it. So how do the two correlate in the sense of, so you did mechanical engineering primarily as your vocation, but then you switched over. What was that road like?
Yeah, back in Serbia, I first graduated with a mechanical engineering degree, started working in that field, but yeah, just through audiobooks and podcasts, honestly, I got to hear more about AI and learn more about AI. And at some point, I just decided that this is probably the most important technology that we can work on in our lifetime. And I just wanted to be a part of that. At that time, that was like 12, 13 years ago, back in Serbia. There was no really developed IT industry, or at least not in that domain. So the only option for me, or at least the only option that I came up with, was to go abroad and get another degree, and then specialize in machine learning and work in that field.
Interesting. So when you say the most important work that we can do, did you mean that as humanity? Or in what context do you mean that?
Okay, that's definitely a strong statement, so maybe I can clarify it. There are many problems that we are facing, right? And we should be working on all of them, but AI holds great promise to basically supercharge our productivity, our research capabilities, just to to upgrade humanity, right? And as such, any contribution in that domain trickles down to everything else. For example, look at DeepMind's AlphaFold, right? It's an AI system that can fold proteins, which is something that we usually can't do. We can, but not that well. And now a bunch of labs and research institutes are using it for researching drugs and medicine and just making new discoveries.
You have great foresight. That was going to be one of my main questions. So basically, I watched that podcast that Demis Hassabis, the founder of DeepMind, had with Lex Friedman. And he talked about AlphaFold, AlphaZero, etc., AlphaGo, and talked about the concept of extrapolation versus interpolation. So would you mind kind of giving me a little bit of background and description on that, if it's possible?
So let's try to paint a picture. Imagine you have a cloud circle of dots, right? And if you want to predict some value in between those dots, that will be interpolation. But if you need to predict some value outside of that cloud of dots that you have, that will be extrapolation. And what happens with machine learning and AI, those dots are actually your data points that you're using to train your AI system, machine learning. And interpolation is then just giving answers that are in the domain of the data that you have, while extrapolation would be giving answers and predictions outside of the domain that the neural network was trained on.
Got it. And which aspect is more important for AI specifically?
I think, let me think about that. So it's actually tricky to talk about interpolation and extrapolation in the context of machine learning and neural networks, because neural networks are extremely highly dimensional, and all intuition kind of breaks when you have so many parameters in a neural network. So even what is interpolation and what is extrapolation is not so clear. But I think that both are actually important, right? Because you want a system that can predict well on the domain that it was trained on, but in certain situations, you want a system that can also generalize and extrapolate. And that's the problem, for example, with self-driving cars, right? It's called like a long tail of the distribution. So self-driving cars are trained on so many data, and they can drive well in most situations, and you just don't pay attention anymore, right? But then something happens that they didn't see in their data, in their training set, and they don't know what to do. And in that case, you need to take the wheel and take the control, right? So you want both interpolation and extrapolation.
Got it. And let me ask you a sub question, and then I think we need to take a step back just so you can kind of give me a breakdown of what AI actually is in today's world, because I think that there's a lot of misconceptions, and not in the case of artificial intelligence as in having consciousness, but just in general. I think when people mention AI, they really don't know what it is in the context of today. So one additional question that I wanted to ask you there. So in terms of self-driving cars, you would view those as blind spots that cannot be assessed via the data provided.
Well, real world is quite unpredictable, and the amount of situations and variety of situations that can arise are pretty much infinite. So it's probably impossible to capture everything just with data, static data that machine learning neural network will see once and know how to behave. To achieve level 5 autonomy, which is the real fully autonomous vehicle, we probably will need a qualitative jump in AI capabilities.
Okay, so now that you put it in quotes, let's take a step back here. So, can you give me a little bit of breakdown of what AI means in today's world and its applications?
Yeah, sure. So, AI is it's an old field. Like since ancient times, people and humanity dreamt about like creating automata and like robots. But it started around 1940s, 1950s for real. And it's just an umbrella term for many things. Today, we equate AI with mostly GPT, ChatGPT, if you're being honest, right? So many people are just exposed to AI through ChatGPT, and they think those things are equal. But yeah, AI is an umbrella term. It encompasses many different techniques for creating intelligent systems. Neural networks are one method, but there are multitude of others that are used in different domains and different problems. Does that answer the question?
So kind of, and I'm going to be a little bit nagging here because I really want to drill down in terms of the terms that you're using. So, what is a neural network? And then I'm going to ask you also, what is the large language model used in those neural networks?
Sure. Okay. I should have prepared my textbook answers. So, neural network is loosely inspired by human brain. And it's a network of nodes. You can imagine it as series of layers where each layer is a node. Each layer is composed of rows of nodes, and all those layers and nodes are interconnected. And you put data on the input side of that network, and then you just run a pretty much basic matrix multiplication. And at the end of that network, you get the output answer. That's a really simplified explanation. And that's only something that we call multi-layer perceptron, which is the most basic neural network. But we have much fancier techniques and methods to do AI.
I love how you said it's a simple answer. I was going to ask you, okay, explain this as if I'm 5, explain this as if I'm in high school, but you went to about a master's degree level here with the terminology. But okay, I'll let myself and others Google the terms because I don't want to drag you on with the terminology. So when we look at AI in the context today and in the future, so we've been listening, I think, for the past decade, this term, the singularity, right? Where humans and machines merge. Now, from your perspective, is that really feasible? And how would that even look like without infringing on so many pillars such as religion, spirituality, consciousness, etc.?
Sure. So I actually like a slightly different definition of singularity, not as a merging of a human and a machine, but as a point in time at which we are unable to predict future with any certainty because of the pace of the development, because the pace of the development is so fast. As for your question, will we ever merge with a machine? We already have some examples of that where people have their brain implants, right? Neuralink from Elon Musk is now in use quite often, but they're not the first nor the only company doing that. It's a fairly old line of research. Even the implants for hearing impaired, right? Those can be seen as merging of a man and a machine. But yeah, in the future, I fully expect us to have much better implants that will enable us to interface with digital world seamlessly.
Interesting. And what are the this is kind of a very forward-looking questions, and you might not have the answer, but what do you think the kind of the guardrails and the safety standards are that we need to set up today in order to prevent any mass malfunctions and be on the wrong side of evolution moving forward? That's a loaded question.
It's a
Super
loaded
loaded. But I know I'm really wondering because, a lot of people talk about the benefits, but I think, Elon is the one that really talks about the drawbacks and pushing Congress to really put legislation in place. But, those people are 85 years old. They don't know what Google is basically. And how would they put in laws that would prevent, the progression of this technology that only a handful of people understand? So what do you see as those guardrails and safety measures that need to be undertaken?
So it's interesting because AI safety and AI existential risk is again not a new thing, but it was before large language models and GPT. It was largely kind of on the fringes of academic discussion and small clubs in San Francisco, right? But now it's very popular and it's important to discuss that aspect. There are two sides to it, as how I see it. One is more applied to us today, but the other one is more long term. And when it comes to the stuff on the ground right now, we have to think about fairness, about bias, how machine learning systems can be used for bad purposes, right? For deep fakes, for scamming people. So that's one aspect that we can already kind of regulate, and most of those things are kind of regulated because you're just not allowed to scam people regardless of what you use, right? And I think that people in charge of that are handling it well. But when it comes to the existential risk of some super intelligence, that is very vague, and not everybody is on the same page. Some people do not believe that we'll ever have a superhuman AGI that will want to enslave us or kill us. On the other hand, different group of people thinks that it's just natural and inevitable, in the same way that, for example, us as humans, we don't care that much about ants, right? We build our highways and it is what it is for ants, right? And I would say that there is no good solution for that right now.
Right. I mean, it seems. Did you have anything else to add
No.
there? I mean, it seems that we are definitely far away from true AGI or really AI in that context. But I really want to get to one point that you brought up that I want to dig deeper in. So you mentioned one of the things that you mentioned in terms of safety was bias. Now, I agree. Obviously, people generally are putting safety measures so that others cannot be scammed from a legislative level. However, when we talk about bias, just in the last 5 years, we've seen, shadow banning on Twitter prior to Elon acquiring it, and how government agencies have been involved in even kind of the development and blockades within some social instances. So when we talk about the developers that are actually working on these models, right, irrespective of the quality of data, how do you actually eliminate bias? Because it's almost impossible to be objective when you are a person working on your own model.
Yeah, there's an even bigger question. Do you actually want to eliminate bias? Because bias comes from your data, and data comes from the real world, right? Mm-hmm. So in some instances, it's just the state of the world, right? And is it up to me to change that and make my model less representative of real world, but more fair and less biased? Or should I just make it so it better models the reality, right? So even that is not there's no clear answer for that. But in terms of the techniques that we can use to overcome some bias, it's, first of all, we should pay attention how we sample our data, how we collect our data, because if we only collect our data from American population, right, we won't capture anything about African population or Asian population, right? So just be mindful and rigorous how you collect your data. And then there are also tests to kind of estimate the bias of your models. There are methods during training of neural networks on how to eliminate bias. So yeah, there are ways.
So on that note, irrespective of bias, so when we look at the biggest challenges in ML/AI development, so when we look at those sources of data that come from the real world, right? When we look at the labeling, when we look at the actual model generation, so what do you see as the biggest obstacle right now in terms of all of those aspects?
Yeah, there is a lot of people suspect that there was a OpenAI conference, but the Dev Day yesterday, right? And they kind of introduced a new model that's multimodal. It has audio and image. Yeah. But the actual performance is still on the level of previous GPT-4 from 1 year ago. Mm-hmm. So a lot of people suspect that even OpenAI is hitting a data wall. And even though they have insane amount of data, not just what's available on internet, but they have armies of people to actually generate data just for them.
Right.
It seems that it's getting hard and there are diminishing returns. At least that's one of the opinions, right? But if you ask leaders of those companies, like actually Mark at Meta and Sam at OpenAI, they claim that data is not an issue and they can scale their models even more and gain even more performance. But we'll see. Historically, and I would say in general, data is the biggest issue for machine learning, not just for large language models, but for any computer vision model or whatever you're doing. To have a good neural network and a model, you need good data. In industry we say garbage in, garbage out, right?
Right.
So yeah, data is the most important thing. And with enough high quality data, the differences in models become very small. Basically, if you have one large language model that uses one technique and the other language model that uses slightly different technique, if there is sufficient data, sufficient good data, both networks will kind of perform similarly.
So both networks will kind of come to the same output, even though they have the underpinning of a different backend, but at the end it will be a similar output. Or of the same quality. Let me correct myself.
I would say same quality, not necessarily output.
Got it. Clear. So when we talk about, we've seen massive growth in chip stocks the last 2 years, especially, NVIDIA, AMD, TSM, etc. So what are those resource constraints outside of data and outside of, manpower that are pushing, the AI revolution forward? And when does it become a commodity?
There is a famous essay by a famous researcher, Rich Sutton. It's called The Bitter Lesson. Mm-hmm. And basically his hypothesis and his lesson for the world is that the only thing we need to do is actually scale compute. We don't need to come up with any fancy new learning techniques and fancy new models. We just need to throw more compute, and more compute is always better than anything that kind of clever humans can build on the software side, mm-hmm. right? And I don't see the hardware race slowing down or stopping. I think that chips are literally the new oil, and it will remain like that.
That's a big statement. I love that. Okay.
It will remain like that for the foreseeable future. Obviously, we have kind of two different tiers. One is high performance computing for data centers, right? For training these huge models. Mm-hmm. But then we also have chips that have to run on the edge and run models locally on your phone or on your whatever thermostat. So yeah, those are two completely different architectures and tiers of chips. And this is not an investment advice. So
I love that. Yeah, Marko sips on AI. So let's get into that a little bit. So you've worked in robotics for many years in embedded closed systems. So can you give me a little bit of a breakdown in terms of the AI applications, or not even just AI, but the differences in those embedded systems, cloud computing, etc.
Yeah. Robotics is also kind of having a moment right now with all the humanoid robots and all that stuff, but maybe that's for another time. When you have systems that operate in real time, in real world, like self-driving cars or autonomous mobile robots in factories or robotic arms on the factory lines, you want decisions to be made almost instantly, right? You don't have time to take the data, send it to the cloud, process on the cloud, then put it back to the robot, and then robot does something. It's just not feasible, right? That's not how factories and real world operate. So you want that compute to happen on the edge. We call that on the edge, basically on the device, on the robot itself. So for that purpose, we have those embedded systems, basically systems on the chip that have certain hardware architectures that can efficiently run neural networks or some other machine learning models, right? And then on the software side, we use a bunch of different techniques to kind of optimize neural networks to run efficiently on that hardware. So instead of requiring full 64 bits of precision for the number to represent a number in a computer, you can use maybe just 16 or even less, right? Or instead of using a complete neural network, you can kind of discard some parts of it, and then the computation is much faster. And again, both are quite essential, both compute on the edge and the cloud. The cloud compute comes with some privacy concerns, right? And in industry, that's also very important. A lot of our customers that we worked with were hesitant to have anything with the cloud in that respect, because then you're in a factory, you're manufacturing something, there are trade secrets. They don't want that data to be sent to some Amazon cloud, and then who knows what happens, right?
Yeah.
They want to contain everything in their system, in their network.
Got it. So basically, when we look at these embedded systems that you just mentioned, and I definitely want to touch upon the robotics kind of novelties that you were mentioning. So, when we look at outside of the robots that are utilized today purely for assembly lines, or Amazon warehousing robots that are replacing humans in small capacities for now. So you won't have the answer to this question, but what is the kind of step needed rather from that hardware that's implemented into locally on the machine so it can operate its own neural network without any cloud input? How does that differentiate from consciousness really?
Oh my God. I do have an answer for that.
Okay.
It's, again, a very loaded question. First of all, I don't think we even have like a good definition of what consciousness is.
True,
right?
Absolutely.
A famous philosopher, David Chalmers, kind of separates it in an easy problem of consciousness and a hard problem. Easy problem is basically to figure out how our brain computes and how we have attention and how we process information. And we kind of know that, not really completely, but we have some idea. And then the hard problem of consciousness is qualia. And qualia is, again, a weird word. It's basically your subjective feeling, right? You're feeling right now sitting in this beautiful setting, right? Or your feeling towards your family, right?
Right.
We have no idea how that works, why that exists, and what it is in the first place. So now trying to kind of project that to an AI and robots, I have no idea how to do that. It's not clear if that can arise in a computer chip. Maybe it can, who knows?
Yeah, go ahead.
But it's also not, it is quite possible that we will reach much better AI systems and more general AI systems without having them being conscious. And to be honest, I kind of don't want them to be conscious. That will be very weird. I don't know. I like to see them as machines, and that's it.
So, what are those previously mentioned then leaps in robotics that you were mentioning or starting to mention?
Yeah, robotics research is awesome. It's super fun. Then when you go to the industry, reality is slightly different because your customers don't care about robots, right? Nobody, when you operate a factory, you don't care about a robot. You care about your product and your production line, right? So whatever solves your problem is good for you, right?
I would disagree. There are a lot of, there are a lot of customers. Well, I'm not gonna seclude only Japan, but there are a lot of industries where robots currently are used for nefarious purposes. But yeah. Generally, they don't care about robots. Yeah.
And then what happens in industry, you kind of become conservative and rely on true and tried methods to build these systems.
Mm-hmm.
You're not using cutting edge AI. You're not using cutting edge research from labs. But that's fine. You have to build a successful business. And in terms of what's happening with robotics now, so it seems that there has been a lot of focus on humanoid robots that have been historically very challenging to make and operate. But there are a couple of companies that have very flashy demos. I don't know how good they are. Obviously, Tesla is one of those. Boston Dynamics is another one. But there is few more that have like more lower cost options. So we'll see how that goes. But then there is an intersection between robotics control and large language models, right? Because these large language models can serve as a brain for the robots, right? And robots, through these large language models, robots can kind of, again, quote unquote, reason in real world. They can understand, again, quote unquote, understand that your dishwasher is here, your dishes are here. It has to pick up some dish from here and puts it in a dishwasher. Historically, we would do that by hard coding, like literally programming if this then that. But now with large language models, and some other methods, we can do that in a more general and unconstrained way.
Got it. So yeah, one thing that I wanted to get back to. So just to kind of clarify. So when you said we obviously don't want robots to be attached to the cloud computing because of latency. We don't want the Tesla car to be attached to some wider network because because of the delays ultimately, right?
Yeah.
Okay, got it. Clear. So let me jump in then to your life in Japan because in terms of the progressions of robots and robotics and just generally the evolution of technology, there is leaps and bounds in front of, for example, what we see in Europe, not potentially US, but the application of robots. It seems Japan in many different, especially the humanoid ones, in many different contexts is widely used. So how was life for you there?
Yeah, so at the time before Japan, I was actually living in Moscow, and I wanted to change. And obviously, at the time, I was in Russia, but I lived in Serbia and I lived in US, and then I never lived in Asia. And I was like, okay, maybe I should try that type of culture, right? Whenever you immerse yourself in a different culture, you grow, you learn a lot. And given my interest and background in robotics and AI, Japan just seemed like a logical spot, right? And I didn't know much about Japan, to be honest, just what I heard like from other people. And I've been to Japan before. And it's a big difference compared to like Western world in Europe or US. It's a different culture with its pros and cons, right? And you just have to get used to that. Japan itself is a beautiful land, beautiful country. Food is amazing.
Right.
People are generous and kind, but there is a huge language barrier because English proficiency in the country is not that high, and I don't speak Japanese, unfortunately. So at least for me, it was challenging to connect with native people. But luckily, there is enough expats in Tokyo and Japan that it was not a big issue to have like my own circle of friends and just have an enjoyable time.
Right, but so how did that though translate into your work? Because I mean, you were in a massive leadership position, leading a big team, and also, from what I've heard, I've never been to Japan. From what I've heard, no matter how much you integrate within society as a foreigner, you're never viewed as Japanese. Even if you spoke, Japanese, even if you've lived there for 40 years, you're always kind of on the outskirts of society, and different things apply to you. So, both from a personal and also business perspective, how did that look for you there?
Well, I was lucky enough so I worked for 2 different companies in Japan, and I was lucky enough that both were kind of they were startups, but more international and open-minded. So I didn't experience the negative side of corporate culture of Japan. But yeah, especially in the position at Ascent as a CTO, we had a big team and a complex product, and our CEO was Japanese, and you just learn to adapt and work with them, right? You have to have a growth mindset.
The classic.
Yeah. And it was challenging at times. There's a great book called Culture Map, and kind of explains differences between Eastern and Western cultures and captures that well. I think that there's always a diagram that I go back to when I think about Japanese corporate culture. And it has 2 sides. On one side is like a Venn diagram of like for the Western culture, where purpose of a meeting is to gain clarity, right? While on the other side, purpose of a meeting in Japan is to maintain harmony.
Okay.
And that is both good and bad. Bad side of it is that people are not as free to speak up and maybe have a different opinion than the elder in the company or their boss, right? And they're shy of asking questions. So meetings can be unproductive. Let's put it like that.
And very unilateral, right? Because
Exactly,
so that's really strange. I mean, maybe from my perspective, what cultivates growth is something Jeff Bezos mentioned. So how they start off kind of meetings in Amazon is they always let the most junior person talk. Because in his view, if Jeff is the first one that openly says something on a topic, he might influence the initial thought of the junior employee and thus change his perception. So in your kind of personal experience, how did you navigate those waters where you kind of had to stray away from conflict?
Yeah, so first of all, I fully agree with that idea. And if you are in a leadership position and if you are senior, I do believe that you should let other people speak first and just create a safe space for them to express their ideas and not shut them down, right? In terms of my experience in Japan, yeah, it was not always rosy. We had disagreements, and actually not at some point, but I was the only non-Japanese member of the executive team, right? So I would always be the one to kind of ask questions and just rock the boat, right? Sometimes they would appreciate that, but I'm sure that sometimes there's like, oh my God, again, this gaijin, like asking questions.
Gaijin?
Gaijin is a kind of word for but it's a word for a foreigner.
Got it.
But it can be seen as a derogatory term, but it's not. It's like whatever.
You should have learned Japanese. You would have heard behind closed doors, because they didn't even have to speak behind your back. They were like, speak Japanese right in front of you. So when it comes to the sources of information that you use for your own personal kind of expansion of knowledge in AI, or just general kind of upkeeping with the industry, what are those sources that you can recommend that you personally like to kind of curate and look at?
Yeah, good thing about machine learning and AI is that the barrier to enter is very low. So, for example, if you want to be quantum physicist, you need to, get the PhD postdoc and well, I don't want to say that you don't have to study for AI, but like resources are widely available, right? You can go online, you can Google and find everything. Basically, most of the things are open source, and books are free to read and access. For me personally, nowadays I get a lot of information from Twitter or X. I have a curated list of people that I follow that are from the industry whose opinion I value, and they always post good content and good references to other articles or blog posts or new research. So I think that's mostly how I get information nowadays.
Got it.
Which might be a bubble. I'm not sure.
Might be a bubble. No, I mean, it's really miraculous how even on YouTube nowadays, previously we had like things like Khan Academy, but now even on YouTube you have Stanford, MIT, Harvard classes just being put up front for the public to look at and learn from.
Yeah, that's true. So actually, given that, as I said, my background was in mechanical engineering, right? And I didn't have a lot of programming experience in my college or high school. So the way I learned programming was through online courses.
Right.
Yeah. So I was doing like MIT X, something like that, or whatever those platforms were. And yeah, I just did a bunch of courses, did a bunch of projects, and yeah.
Got it. I heard you say when we talked about your kind of inception, or rather the beginning of your AI journey, that On Intelligence, the book, kind of drew you towards it. So can you give me a little, not obviously a synopsis, but why was that kind of the breaking point or the tipping point?
If I remember correctly, that was probably the first book that was like specifically about AI, and actually that book is not about AI at all. It's about human brain and how human brain works, right? But indirectly it's about AI, and it has some chapters about it. And I think that was the first book on that topic that I read, or rather listened, on my way back and forth from work at that time. And yeah, I was just fascinated by how complex and complicated human brain is, and how little we actually understand. We understand some mechanics, right? How neurons fire, how they're connected, but we don't know how memories are stored. We don't know how information is actually processed. We don't know how feelings are, what they are, right? So it's just a giant mystery that is very inspiring.
So yeah, ultimately, how could we build something like the brain we have when it comes to the system that we're trying to build as AIs? So it's interesting how you say that we do have, as you mentioned, some notion in kind of the management systems of the brain, but fundamentally we don't understand the entirety of it. So how could we ever build, or rather, how could we build that system that replicates that same idea?
I don't know. So there are several schools of thought when it comes to building AGI, and one of them is to basically completely recreate human brain, and then we hope that if we recreate human brain in silico, then it should be like human level intelligence. But some other people argue that no, we don't need to do that. We just need to scale these neural networks, and it will be enough. But I do think that intelligence is substrate independent, meaning that it can arise. It doesn't require human brain. It can be built from silicon or some other material, right? But how to actually build it? That's a $1 gazillion question.
$1 question. Yeah, I mean, what maybe I was more referring to was the concept of the spirit, right? And what actually makes us us, or what am I? That was not a question. It was more of a rhetorical question. We don't need to get philosophical. Don't worry. So one last question, because we've had we didn't have really debates about this, but I wanna hear your perspective in a more coherent manner. So you are what I call, I'm going to be really harsh now, a Bitcoin truther.
Oh no!
So why does Bitcoin, like, what's the attraction there ultimately?
What a setup!
What a setup!
There are many levels to it. one level is that I do believe that there has to be a separation of money and government, which is what Bitcoin allows and represents. I also think that in a way it's like a very democratic system and built for the people, because there is no CEO of Bitcoin, there is no company that runs Bitcoin, there's just a bunch of companies that are running their mining operations, there's a bunch of people running nodes and a bunch of other people using Bitcoin for transactions. And any development that happens on the Bitcoin is literally just a consensus of all these people. And I don't know, I just find that very beautiful as an idea. And then also the background of Bitcoin is fascinating. You have like a character, someone called
Satoshi Nakamoto.
Yeah, right.
Posting on 4chan.
Dropping the white paper and just the first implementation of the system, and just seeing that through for some time, and then just disappearing.
Oh, by the way, sorry to interrupt. Did you see that? And I actually checked this. Did you know that all Apple laptops prior to 2019 had the white paper stored?
I think I've seen that. Yeah.
I checked it, by the way. It's real.
There?
Nice. It's actually real life.
Okay.
That is incredible. Some developer at Apple put that as a Easter egg.
Yeah.
But yeah, go ahead.
Yeah, it's just again, it's a beautiful idea, right? Somebody came, gave us this gift, and then just disappeared, right? We don't know who it is. We don't know what their motives were or are. And it's up to us to do it whatever we want, right?
So from your perspective, it's more of a democratization and separation from governments, and a global way to, instead of resorting to barter as we did in the hunter-gatherer times, or using currency, fiat. This is a way where we don't need to be monitored, where we don't need to be vetted, and simply can transact on this ledger.
Yeah, basically the promise is that you don't need the third party to guarantee for anything. Right now, if you and me transact with like Stripe or whatever, there's like intermediary that guarantees that everything is legal, right?
Right.
But Bitcoin says, "Oh, fuck that. We don't need that." It's blockchain is enough, right? That's the guarantee itself, and all the work that goes into running the blockchain. And again, it's a great concept and great idea. Also, you mentioned fiat money, right? I'm not like a monetary expert or economist, but it does seem that governments play quite loose with money, and it's not clear like what is the actual value of it. While some people also argue that Bitcoin is also not backed by anything, but I disagree with that. I think that Bitcoin is backed by all the energy that goes into mining it and maintaining the network. That's a huge amount of capital and energy that's being constantly spent on maintaining and running the network. And in a way, Bitcoin allows us to monetize that energy directly, right? There are a couple of instances in which people built mining facilities next to the remote power station, right?
Mm-hmm.
For example, it's a remote station, hydro plant somewhere, and it can't distribute power well because there's nothing around, right? They just built a mining facility there and started using that free energy to kind of monetize it, right? There was a story about a national park in, I think, Kenya or somewhere like that. During COVID, they didn't have any visitors and they were running out of cash, but they had a lot of I think geothermal or maybe hydro. So basically they just put the miners there and started monetizing that. And that's how they sustained the park, right?
Very interesting. From what I'm hearing you say, I either set up a mining facility near a energy producing plant, or I grow a garden and put the cows out to pasture, and then...
So there's an interesting interplay. So you could actually utilize... The mining of Bitcoin is a very computationally intensive process and produces a lot of heat. So you could actually capture that heat and use it for some industrial processes. For example, for drying plums or whatever. So you can do that in Serbia.
Oh, to make rakia.
Yeah, exactly.
Great stuff, man. Great stuff. Well, thank you so much for being on the show, and it's been an absolute pleasure, man.
Thank you, man.
Thank you.